Welcome to Chapter 6, Lesson 1. Let's start now with our new chapter, Exponential, Logarithmic, and Inverse Trigonometric Function. Let's talk today for the properties for the exponential and the logarithmic function. Now, our first lesson here, which is exponential and logarithmic functions. In this section, we will review the some properties for the exponents and logarithm. We will revise with you the algebra, and also we will develop results about the exponential and the logarithmic functions. Today, we are going to talk about the properties of the exponents and the logarithm. Let's now revise what did we talk on algebra. Let's talk about an irrational exponents. Then our irrational exponents, like when I told you b squared, or b cubic, or b to any rational number. Now, what is the irrational exponents? The irrational exponents, like if you have a number b with a base of 0.5, with a base of -1, with a base of -4, with a base of 5/2. These are an examples of an irrational exponents. Let's talk about their properties. Now, the first one, b to the power -n is 1 over b to the power n, like b to the power -2 is 1 over b squared. This is for here. b to the power -2 is 1 over b squared. I will flip it. I will write the reciprocal of b and the opposite of the exponents. This is the first one. And we have to know that b to the power 0 is 1. And if we have now a rational number that is raised to a number here, like as an example, b to the power p over q, b to the power 4/3. What did we say? We say that it is a cubic root of b to the power 4. That's what we talk about them in grade 8. If we have b to the rational raised to an irrational exponents, I will write it as cubic root of b to the power 4. And if I have a negative power, I will, the first step, write the opposite, or sorry, the reciprocal of b, and then which is 1 over b, and then I will write the opposite of the exponent, which is positive. And also, if I have now, as an example, b to the power -2/3. What did we do? The first step, as I told you, if you have a negative power, we have to write the reciprocal of b, which is 1 over b, and then you will look at the exponents. What is the exponents here? It is -2/3. What is the opposite of -2/3? It is positive 2/3. Then after that, 1 over. Now b to the power 2/3, I can write it, or I can convert it as a radical. So it will be square root of b cubic. So b to the power -2/3, it can be written as 1 over square root of b cubic. Is it clear?
Yes, teacher.
And then also, all of us know that if we are, the square root is only for positive numbers. But if we have if we have 2 to the power half, it will be a square root of 2. But if we have negative 2 to the power half, it will be square root of negative 2. And what we call this type of numbers, or this type of values? I, bravo, which is an imaginary values. So we have to say it is square root of 2 times square root of negative 1, which is square root of 2i. Now let's continue here, or let's revise the properties. Now, if you have two bases that they are the same, and they are multiplied, and they have different exponents like 4 and 3. When you multiply them, what you have to do? You have to add the exponents. So we have to say 4 plus 3, which is 7. It will be b to the power 7. And if you have now two bases that they are divided, and the first one here is 4, and the second one here is 3, how it will be? You have to subtract the exponents, which is 4 minus 3, which is b to the power 1, or b. So if they are multiplied, you have to add the exponents. If they are divided, you have to subtract them. And if I have a base raised to the number 3, and this one is raised to another exponent like number 4, what you have to do here, you have to multiply them. So you have to say it is b to the power 12. Now, before going now to the exponential, or before continue, do you have any question here for the irrational exponents?
No, teacher.
No.
Okay. Now let's talk about the family of the exponential functions. The functions that we talked about them before, which is f of x equal base to the power x. If we have base to the power x only, we say that it is an exponential expression. So we have, if we have b to the power x only, we say that this is an exponential expression. If we have b to the power x equal 4, we call it exponential equation. And if we have f of x equal b to the power x, this is an exponential function. Now this exponential function with a base b, because later on we will talk about with a base e. So exponential function with a base b, such as you say f of x is 2 to the power x. So if I have a function that we have a number base with the base b, a number raised to x, to a variable, I will say this is an exponential function. Or if we have it as half raised to the power x, half is a number raised to the power x, this is an exponential function. If we have it as by, as an example, to the power x, this is also an exponential function. So be careful. Exponential function, that's mean we have a constant number, we have a number raised to a variable exponents. If you have a number raised to the variable exponents, I will say that this is an exponential function. But if you have a variable raised to a number, this is not exponent function. This is a quadratic, or x to the power by, or x to the power third. This is not an exponential function. So be careful. The exponential function is a number, a constant number raised to a variable exponent. Is it clear?
Yes, teacher.
This is the exponential function with a base b. I have a number raised to a non-variable exponent. Now, let's talk about a particular base of the exponential function, which we called it natural exponential function. Here, in the exponential function with a base b, we say that we have a number to the power x. In the natural exponential function, I have to use an irrational number, which we called it e. This one, which is equal to 2.718282, as you see. If there's an e raised to x, we call it a natural exponential function. So if you have 2 to the power x, it is an exponential function with the base b. If you have a function or exponential function, but the base here is not a number, is not a constant number, it is an e. It is a natural exponential, so it is an e, so we call it a natural exponential function. Did you take it before?
Teacher,
Grade
can you
11.
repeat it, please?
Did you take E before?
No, teacher.
No.
No? Okay. So the first step for the exponential function with the base b. Is it clear? Is it right? I think you took it in grade 8. Like this.
Yes.
Yes, teacher.
Okay. Now today we will talk about a special case of the exponential function, but here with not a base b, with not a number 2 or 5 or half, with a natural number, which is e. If we have e to the power x, we call it natural exponential function. So, okay, so if I have here e to the power x, this type of exponential function, we call it natural exponential function. Why we say it's natural? Because here we have an e. We don't have a number, a constant number. We have an letter e, which is an irrational number. So how we deal with it is we deal with it as any exponents. Like if you have e, two bases, they are e, x to the power 1 and x to the power 2, you will add them as we did before. But here we don't have a base b like number 3. I have an e. We said before, if we have 3 to the power 4 times 3 to the power 5, we take the same base, one of the bases, and then I will add the exponents. Here, if we have an natural exponential function, we deal with it as the exponential function with a base b. We have two bases that they are the same. We will add the exponents. This is for it here. Now, do you have your calculator now with you?
Yes, teacher.
Okay. Now, on your calculator here, look at down here, about down. You have 10 to the power x. Did you see it?
Yes.
Make now shift with it. Sorry, alpha with it. What did you see?
E.
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 E to the power 2 is 7.38. So when I'm asking you now to tell me what is E squared, you will tell me that it is 7.38. If I'm asking you now E to the power 7, what is the value of it?
Can you repeat, please?
96.
E to the power 7. What do you have to do? On your calculator, alpha, press press this button, which is times 10 to the power x. When you press alpha with 10 to the power x, you have E. Then say E to the power 7. What is your answer?
It's 1,000.
1096.
Bravo,
1096.63.
1096.63. This is for the natural exponential function. Now, let's talk about the logarithmic function. Now, did you take the logarithmic before? You must take it in grade 9. Did you take it before?
Yes, teacher.
Okay. Let's talk about the logarithmic functions here. The logarithmic function, we write it as logarithm. Logarithm to the base b of x. I write it as logarithm of the base b to x, or of x. This one, that's mean when I have like, here we have n. So that's mean n to the power b equals x. N to the power b equals x. So the exponents to which b must be raised to x. The exponents n that is raised to b must equal x. So n to the power b, which is equal x, I can write it using the logarithm as logarithm to the base b of x equal n. To the base b of x equal n. Let's have now these examples here. Now, when I'm asking you now to find logarithm to the base 10 of 100, what does it mean? That means you have to ask yourself, what is the number that if I raise it to the power 10, I get 100? No, sorry. So you have to ask yourself now, what is the number? Or what is the number that if you raised to 10, you get 100? Let's try. 10 to the power 1 is 10. No. 10 to the power 2?
100.
100. So what does it mean? That's mean 10 to the power 2 is 100. 10 to the power 2 is 100. So when I'm asking you to find logarithm to the base of 10 of 100, that's mean you have to ask yourself, what is the number that if I raised to 10, I get 100? You will tell me, teacher, it is 2. Another example. Logarithm to the base 10 of 1 over 1000 equals what? Now, how did you solve it? You will ask yourself, what is the logarithm? Oh, sorry, 1 over 1000, I can write it as 10 to the power negative 3 to the power base 10. So that's mean, what is the number that if I raised to it, I get 10 to the power negative 3. How can I make these two of this equation equal? 10 to the power something is equal 10 to the power negative 3. So what's the number will be here?
-3.
Sorry?
-3.
Negative 3. So because of that, I will say that logarithm 10 to the 1 over 1000 is negative 3. Is it clear?
Yes, teacher.
Yes, teacher.
So in easier way, you can write it as logarithm 10, and then here, since 100 is 10 squared, so it's like 10 cancel 10, so it is 2. And if you have logarithm 10 to the power negative 3, or logarithm to the base 10 of 10 to the power negative 3, you can say that like 10 cancel 10, so it will be negative 3. This is another way. Now, the most common logarithm is logarithm to the base 10. But there's another types of logarithm like logarithm to the base 2 of 16. What does it mean? That means I will ask myself, what is the number that I raised it to 2? So I will get 16.
4.
What you have to do? The first step, you will ask yourself now. So you have to ask yourself now here, 16, how can I write it with a base 2? Is it 2 to the power 2? Or 2 to the power 3? Or 2 to the power 4?
2 to the power 4.
2 to the power 4. So here, 16, it can be written as 2 to the power 4. So here it will be also 4 to make them equal. So that's mean logarithm to the base 2 of 16 is 4. Why? Because 2 to the power 4 is 16. 2 to the power 4 is 16. Is it clear?
Yes, teacher.
Yes.
Fine. Now let's have another example here. Type logarithm of 5 to 625. Here, you have to ask yourself, what is the number that if you raised 5 to it, you get 625. Think about it. Yalla.
4.
4. Bravo. 5 to the power 4 is 625. So logarithm of to the base 5 of 625 is 4. Is it clear?
Yes, teacher.
Right. Now, um, okay. Now you have in your calculator a button like log. Did you see it?
Yes, teacher.
Yes, teacher.
Now, this logarithm, it's mean logarithm to the base 10. So logarithm 100 as an example equal, let's solve this one here. Equals what? Equal 2. So in your calculator here, logarithm, this one here, it's only logarithm to the base 10. So if you try logarithm of 100, you get 2. Logarithm of 1000, you must get to 3. Why? Because 10 to the power 3 is 1000. Now, let's continue now. Now, logarithm to the base b of 1, that's mean you have to ask yourself, what is the number that is I raise it to b, I get 1. How can I make any exponential with what to make it as 1? I raise to the power 0. b to the power 0 is 1. Any number raised, we called it 0 exponents. Any number raised to the power 0, I get 1. So you have to know that logarithm of 1 is 0. Why? Because the number that is raised to the b raised to the power 0 is 1. So if I'm asking you now, what is the logarithm to the base 4 of 1? What you have to do, or what you have to say?
4 to the power of
0.
It is 0, because 4 to the power of 0 is 1. Now, and also, logarithm 4 to the of 4, or logarithm to the base 4 of 4 is 1. Why? Because 4 to the power 1 is 4. So this is the most important things. Like they are canceling each other. Logarithm to the base b of b is 1. And logarithm to the base b of 1 is 0. Is it clear?
Yes,
yes,
teacher.
teacher.
Okay. So by now, we talked about the exponential function and the logarithmic exponential function. So b to the power x is an exponential function, and logarithm to the base b of x is an logarithmic function. And there's a relation between them. We say that if we have logarithm to the base b of x is equal n, so that's mean b to the power n is x. And so that's p of x equal. So these are the two we are talking about them. Now, if we have the base, so this one we called it exponential function. But if we have an exponential function, but with a base a, we called it natural exponential function. And here we talk about the logarithmic exponential function. This is, we write it as log base of x. And tomorrow I will tell you about a new type of the logarithmic function with a base e. We called it ln. ln of something. This is an natural, if we have logarithm to the base e, like here, b to the exponential function with a base b is an exponential function. But if we have an exponential function with a base e, we say it is a natural exponential function. Logarithm x it is an logarithmic function. But logarithm with a base e, we will not say it is a logarithm. It will be a natural logarithmic function, or ln. Now this one, inshallah, I will tell you about them. Now let's see here, what is the relation between an exponential and an logarithmic function. As you see here, this is an b of x. This is an logarithmic of base b to the x. So that means they are inverse to each other, or they make a reflection. Here is y equal b to the power x, and here is y is logarithm to the base b of x. That means this line here is like a reflection line that make them, they are like a mirror. Y, or the logarithmic function, is an inverse function of an logarithmic function. They are inverse to each other. Is it clear?
Yes, teacher.
Yes, teacher.
So today we talked about exponential and logarithmic functions. Let's repeat. Here we talk about some of the properties for the exponential function with the base b. We can do the same if we have a natural exponential function with a base e. Thus, we say e to the power x is a natural exponential function. And then we talk about a new things, which is a logarithmic function. It's not exponential, logarithmic. Logarithmic is an inverse of an exponential. Logarithmic here, that's mean if you have, we say that logarithm to the base 4 of 0 is 1. Why? That's mean 4 of 0 is 1. How we read it? We say logarithm to the base b of x. And we said that, as you see here, they are inverse to each other. Tomorrow, inshallah, we will talk about ln. ln, that is a logarithmic function to the base, or to the e, not to the base b. It is log, but not with b now. It is log with b, with to the base e. So we write it as ln of x. This will be, inshallah, our lesson tomorrow. Do you have any question?